Adesso un intervento in inglese per concludere questo blocco. A step-by-step retrofit of a public school in Catalonia, challenging the passive, by architect Micheel Wassouf, director of Energy House Architectos.
Okay, thank you very much. Well, I would like to thank first of all to ZEPHIR for having this occasion to present here a project from Spain. I'm an architect from Barcelona. We started, me with some other engineers and architects 8 years ago with the Spanish Passivhaus platform in 2008, and now we work in Barcelona as normal architects, and also we are a building certifier of passive houses. So we have the lucky situation to have a lot of projects which are passing through our firm. I thought it would be especially interesting for you to show you a public project of a public retrofit of a school in Spain. I suppose that also in Italy you might have several similar issues of public schools, of existing schools with quite big problems of comfort and of very high energy consumption. So we started to get these projects. First of all, we had to convince the municipalities of the interest to go through an energy retrofit. So first of all, we did several energy audits of different schools in Catalonia. I have shown you here some public schools, most of them from the 70s and from the 80s, and even someone from the 90s. Curiously, they all have a very high, you see on the right hand, a very high demand for heating. Besides of dealing with the climate, with a hot climate, as Barcelona is, but as public schools don't have air conditioning, so they have most part of their consumption is the heating, space heating consumption. So you see here these values are calculated with the PHPP. Besides of this problem of high consumption, as I already said, there is a severe discomfort of the buildings. For example, in winter time, the pupils, they can't leave their coats. They have to go to the lessons with the coat carried on. And also in summertime, we had some problems with a teacher which was faint. Let's say they couldn't continue the classes because of too hot temperatures of these buildings. So we've been charged by the Area Metropolitana de Barcelona to carry out these audits, and we had the luck that there was one person in one municipality of Viladecans near to Barcelona which was very interested and knows the passive house standard. So she convinced the major to make a retrofit project, a real project, because first we started with an audit, and then we had this occasion to carry on a project for the retrofitting of this existing school. An interesting issue of this kind of projects is the very limited budget of the retrofit. So we are dealing with, in this case, about 250, 260 euros per square meter for making the retrofit works. So it's really very, very low budget, and I think that may be also for you interesting, and also in Spain for other municipalities, an interesting project, this challenge to carry on an energy retrofit with a very limited budget. So I can show you here some images of the school with a simple, of course, a simple sliding frame with a simple glass, which almost is connecting the classrooms with the exterior of this. of this municipality. We carried on some also CO2 measurements with very simple CO2 measurement, actually not a professional one, but it was enough to convince the major of the problems on the regarding the air quality of the classrooms. You can see we reached almost 4,000 ppm of CO2 concentration. Here you have the limit of the national Spanish limit, the official limit of 1,000 ppm CO2, besides of having a very low air tightness. Curiously, we got these high values, because normally if you have a building with high infiltrations, the tendency is that the CO2 values are not so high, but in this case we had here this phenomenon. We carried also on a blower door test. Actually the frames, as I already said, they were like not existing in some parts of the school, so we had some problems to pressurize the building to 50 pascals, but at the end we got 17 and 50 air change rate of the building. So with the calculation with the PHPP, you can see here, this is a normal value for existing school buildings, probably also in, I don't know, in Bologna, but in Catalonia it's a very normal value of about between 130 and 150 kilowatt hours. Here we have the actual consumption of the school, of the real consumption, and this was with the PHPP, the calculated consumption, so that the gap between these two values is supposed to be the lack of comfort of this school. So you can see here also, curiously, in this more hot climate of Barcelona, of course without air conditioning, very big part of the energy consumption is the heating demand. I said that. So we started with different proposals to reach the Passivhaus, or let's say the NFIT standard. These are technical proposals which are not very special. You may know them all. Standard solutions like changing the windows and putting an external insulation and working the air tightness on these things you may already know. We had here this proposal of changing to PVC windows. That was first of all the architects of the municipality. They were not so lucky with the PVC, because in Catalonia there is some they like more the aluminium frames. We have these prejudices that PVC frames are not so environmentally performant like the aluminium windows, but at the end we convinced them to install or to work with these PVC windows, which are cheaper than the aluminium frames if you work with this very low U values of 1.04 more or less. And in Barcelona, of course, we don't have to use triple windows, so we can work even you see here the photos was triple, but at the end, of course, the window is a double window with 1.0 watt per square meter in Kelvin U value. So one of the challenges of this project was this, as I already said, the limited budget of the municipality, as they had only like 30% of the overall budget of the works to get the NFIT standard. So we had to cut the project in 3 phases. So at the end, it's going to be a step-by-step retrofit project. We have the challenge of starting with the first retrofit in summer of next year, in June. We have, as you know, public schools, we can only carry on the works between 20th of June till 10th of September, so we have 2 months to really do the work, so it's not so easy to organize all the logistic, also dealing with the public procurement and public promoters, so it's not so fast as if you have been a private school, which is much more faster in all these processes. So this was one challenge, and the other one, due to having to work with different steps, 3 steps at the end, we are going to have the first phase with changing the windows and also changing the installing a new ventilation system, as now the actual school doesn't have any ventilation system, of course, but first step is installing new windows and working the air tightness, so we have to install a mechanical ventilation system. And between the first and the second step, we are going to have a situation with some problems of the thermal envelope where the external insulation is not yet installed, so we have to protect the frames 1 year from rain and from the outside weather with special frames. So this ends with a budget which is higher than the normal budget if we would have done everything in one step. So here you can see, due to the limited budget, we can't neither change the situation of the windows, so we have the windows aligned with the interior wall as the same situation of installation as the actual situation. This is due to limitation of the budgets, but as you see, it's everything possible, even if the Psi value, this is the actual Psi value, and here you can see the retrofitted Psi value after the first step. It's lower than the first one, but it's still very high for a passive house. But fortunately, with the climate like Barcelona, these kind of Psi values are still allowed. The only thing you have to control is that you don't have any condensation on this interior surface, and that is the kind of works we have done with the thermal calculation. Here you have the detail of the upper part of the windows, so this is the actual situation, and then you have still this very high U values due to the installation situation of the window. But actually for Barcelona also it is a kind of interest to have the windows in the inside of the walls, so we have also higher solar protection of the building. So as you see, it's not necessarily the North European solutions that are here of interest, but more adapted solutions for Mediterranean passive house. This is this calculation of the first step this summer, which is supposed to be installed this summer. So we have in the first step, we don't have any insulation, so we are going to have condensation in the interstitial condensation in the inner side. This is the inner side of the building, so we're going to have a situation which is not very optimal, let's say, for a building, but as the actual situation already has these condensation problems, so we just have to control this and to make some openings, controlled openings, to get the vapor outside of the building in this case. This is the calculation of the balance of the energy balance of the window before and after the first steps. Then we have here also another challenge is the installation of the mechanical ventilation system. So you have a problem in very often in these retrofit processes that you have no space for installing these gadgets. in a retrofit. These buildings don't have a cellar, so neither the roof is accessible, so you can't install the ventilation systems neither in the roof nor in the cellar, and there is no space in the schools. So you have to look for spaces like the suspended floor here in the bathroom or in some storage rooms to carry out these big machines, as probably you may have the same problem with with very high volumes. You have to justify for the legislation, so you have very big ducts to get with the Spanish legislation, and so this looks like easy, but it's really like a puzzle. You have to have the luck to get also all the ducts outside of the building. We combined also with textile ducts in the classrooms to have also some colors and some more architectonical issues in the building. Here you have some details. Airtightness is a second challenge of this building, as we can't do works inside of the building. We can't make anything on the inner side of the walls, so we have to work on the outside between the, as you may see, this is the existing wall, and this is the capote, the external insulation system. So we are going to try this airtight painting, which now is in Spain also coming in the Spanish market. Seems to be with quite good results in first buildings in Spain. And well, this is the details with the thermal bridge calculation, also insulating the existing roof without putting away the existing roof. We are going to put a new insulation and a steel structure on the existing roof. This is we wanted first of all to work with mobile vertical blinds, but also due to economical limitation, we can't carry out this idea. So at the end, it's going to be a fixed element for economical reasons, combined with textile elements for inside and sometimes also in the outside, and changing the illumination to a more energy efficient solution of the illumination. So this is the simulation with design PH. We did this with design PH because it was faster than doing it manually by the PHPP. It seems as it is a simple building with, as you see here, with repetitive structure of always the same windows, but as you may know, the one who work with PHPP, you have to distinguish between, even if it's the same window, you have to distinguish between different shade situations. So at the end, we had like 518 different windows in this simulation. And we are now in the process with the Passivhaus Institute for the certifying of this building. We are still negotiating with them whether they accept 26 or 25. Normally, as you may know, you have 25 degrees for the summer comfort, and we would like to look if it is possible to get 26% of 26 degrees for the upper comfort temperature. And also we did some changes in the PHPP. We put away the summer months for the summer comfort. So as July and August are the school is closed, so we changed the algorithm of the calculation and put away these 2 months, because if not, it would be impossible to reach this 10% maximum allowed value for Passivhaus certification. So this we have this political also problem that the municipality can't install air conditioning in this school, because if not, all the other schools in the municipality or in the region also would like to install air conditioning. So there is also psychological and a social component in all these ways. But I think to getting to the end, maybe just 2 slides. The interesting message of this project is that it's almost possible to get NRFIT's retrofit project, maybe not certified, but almost certified, with a very low budget. You don't have to have like a normal budget of maybe private property, and you can, as you may see here, we have compared the same retrofit, but with the Spanish legislation and with the Passivhaus with the Passivhaus solutions, and you see here the more costs regarding to the normal retrofit design. We have here this 13 years of payback time, and also similar to what Iliana was telling you with the PHPP, we carried on this comparison with the PHPP with the annuality. So now we have this school with these costs regarded on 40 years of getting the expenses for heating and for electricity consumption higher and higher. As maybe I think there is one slide where you see 5% of inflation of gas and 2.3 of electricity. So the real consumption, if you make the calculation of the annuality, is about 25,000 euros a year. And then this is with the comfort. This is the, let's say, due to the discomfort of the building. And then if you make the normal retrofit of the building, so you have these costs of annuality for the retrofit cost itself, and then you have the less consumption, energy consumption. So it's still a little bit higher than the actual costs. So this is the step where Passivhaus could be interesting, as you have more dispenses for the initial costs. You have this annuality, you got it on 40 years of this value, but with the sum of the energy consumption at the end, you have lower costs as the actual situation. So this is the last slide, just to motivate you if there are some public politicians here in the auditory to do something similar. You don't need to have like 1,000 euros a square meter. You can also already with smaller budgets, limited budgets, get this building to quite very comfortable building after the retrofit. Besides of that, we going to finish it on 2019 probably, so you need some patience to get to the end to this, but as you know, it's always very slow, our business, so it's nothing special. So thank you. I just wanted, Francesco told me also to show you that we are collaborating with Italy, with other projects here. We are making a retrofit of a public building in Logroño, in central Spain, in northern Spain. This one is really with a very good, interesting budget, with 1,000 euros square meter. And also here works are starting, and with ZEPHIR we are certifying this building. So thank you very much for your patience, and if you have some questions, ask.